Hello and welcome. In this tutorial, we will learn about lists data type in Python, so let's get started. In the last tutorial, we saw that there are different data types in Python including floats, integers and strings, and we also learned how to use variables and assigning values to them. The values that were assigned to the variables in the previous tutorial held only a single value with strictly one data type. A limitation of using variables in that way is that it can only hold a single value with a certain data type such as x is equal to 4 plus 3 that holds a single value of 7 with an integer data type. Therefore, in this tutorial we are going to see how to deal with this type of situation using lists. Using lists is not the only technique, and we are going to study more options in this course. Now, we previously looked into a serial table consisting of multiple values, each of which is called the data point. For example, the cereal Almond Delight is a data point in the name column. The corresponding protein content for the Almond Delight is equal to 2, which is also data point in the protein column. We call this table a dataset since it has a collection of data points. Those data points need to be saved somewhere for further data operations and manipulations. Creating a variable for each data points makes it very difficult to perform data analysis, as you will have a large number of variables equal to the number of data points in the dataset. To avoid this, we can use lists to group data. With lists, you can save a grouped data in a single variable. Also, lists not only hold multiple data points in a single element, but also a combination of different data types as well. 3 things define a list: square brackets and one or more data points separated by commas. You can also define an empty list without any data point as such by have opening and closing square brackets only. There's some use cases where you need to define an empty list for further processing of your data, but do not worry about this at this point in the course. So, for the first row in our dataset, we can create a list to group all info about the cereal 100% bran as such. As you can see that a list can hold one or more data points with multiple types of data including strings and integers. However, you have to be consistent with the order of data in all your lists. For example, first entry is always cereal name, followed by protein, fat, fiber then carbo for all rows. This is important to avoid mixing your values when manipulating your data. If you find the type of the variable row 1 or row 2 using the type function, you will find that the type is also called a list. Therefore, a list is another data type in Python. Although a variable assigned with a list containing variations of data types such as floats, strings and integers as elements defined in it, this variable is still a list type. Going back to our list defined in the variable row 1, you can see that it has 5 entries. To count the number of entries in a list, you can use the len function, which is an abbreviation for length. The length value is saved in the row 1 len variable. Note that you can also print the length of a list using the print function without the need to save it in a variable if you wish to do so. Each element in a list is positioned and located in a certain entry. This makes each element in the list to have a unique location. In Python, the location of the data point entry is numbered according to what is called an index number. An index number is a unique number which represents the location of the data point in the list. The index number always starts from 0 for the first elements and incrementally increases by 1 following the next data points. This is called positive indexing. Index numbers are used to access the value stored in a list. To extract the value stored in a list, you need three things: the name of the target list, square brackets, and the index number of the element you wish to extract. As you can see in this code example, the element 0 variable is assigned with the first element in the row 1 list since the index number set is 0. However, the data type of the variable element 0 corresponds to the data point extracted from the list, which is string in this case. Now, it is great that you know how to access the elements of a list, but you need to know the importance of it. Accessing lists' elements makes it easy to perform many operations. Going back to our calorie calculator, you see that each value of the macronutrients is now changed according to its index number, corresponding to its location in the list instead of manually tracking and typing the numbers for each one of them. Another convention of indexing a list is by using the negative indexing method. Negative indexing is similar to positive indexing except that negative indexing starts from the end of the list, with a -1 for the last element and -2 from the second last element and so on. Therefore, you can access the same element using either the positive or negative indexing technique. For example, if you wish to access the second element in the list having integer value of 4, then both of the following techniques are valid to access this value in the list. You saw in the previous example that we were able to extract specific values from a list using positive indices, according to the location of the macronutrients in row 1 list. There is a second technique by which you can extract values from a list. This technique is called list slicing. In the list slicing technique, we are interested in extracting elements from a list when the desired indices are consecutive. For example, you can access elements starting from index 0 till index 3, or starting from index 2 till index 4, and so on. This is the syntax by which you can access elements in a list using list slicing. You have the list variable you want to slice followed by the square brackets, then the starting index number followed by a colon, then the last index. It is important you know that the start index is inclusive and the end index is exclusive, so let us see this in more details. This table shows a summary of list slicing techniques. In the first case, we are setting the range to be from index 0 to index 3. Since the end index is exclusive, only indices 0, 1, and 2 will be considered for element extraction. In the second case, we are setting the range to be from index 2 to index 4. Since the end index is exclusive, only indices 2 and 3 will be considered for element extraction. In the third case, the end index is not written, so the extraction of elements will start from the start index to the end of the list. Therefore, indices 2, 3, and 4 will be considered. In the last case, the start index is not written, so that element extraction will starting from the start of the list to the index before the end index since it is exclusive. Therefore, only indices 0, 1, and 2 will be considered. You can pause this video to study this table in more details. We previously saw that we can represent each row in a dataset as a list on its own. In this way, we were creating single individual lists that represent a dataset. However, we can do it in a better way by creating a list of lists rather than having single lists. As the name suggests, a list of lists is a list that combines multiple lists in a single variable. In this example, the individual lists are converted to a list of lists in a similar syntax of any list we have seen before. This list of lists incorporates opening and closing brackets, separation commas, and the an entry at each index location. In this case, each entry is a list by itself. Now, having seen the syntax of a list of lists, you need to know how to access the elements inside the list of lists. Previously, we saw that we can access an element in a list using an index with this syntax. However, in the case of list of lists, when using the same syntax, you will access the nth list in the list of lists. Therefore, to access an element in a list inside of a list of lists, you need to have two indices to do so. The first index is to access the nth list in a list of lists, and the second index is to access the nth element in the nth list. For example, here we are extracting two things in this code example. First, we are extracting the first list in the dataset variable, which is a list of lists. Then we are extracting the third element in the first list in the list of lists. Now that we know the nature of lists in Python and their usage, we need to know 4 important operations that you will frequently use. We will be looking at list repetitions, combining multiple lists, append and index methods. In the list repetition operation, you can repeat the elements of a list n number of times. In this example, the integer elements 1, 2, and 3 are repeated 2 times. This is the syntax by which you can repeat the elements of a list. The n variable in the syntax is the repetition factor of the elements. For example, if n is equal to 2, then the number of elements repetition is 2 times. The multiplication symbol in the syntax is not a mathematical operator that mathematically multiplies numbers in a list, but it is just a repetition operation for lists, just like strings. To see the syntax in action, here we have a multiplier value that is equal to 3, and a variable x that has strings values of Python, R, and Java. The variable y holds a list value with the repeated elements of x, as you can see in the output of the code. The string values are repeated 3 times as per the value of n. Now, let's look at the second operation, which is combining multiple lists. As the operation's name suggests, we can combine multiple lists into a single one. In the case, we are combining 2 lists having integer numbers into a single one. This is done using the plus operator. Again, the plus operator in this case does not mathematically add numbers but appends new elements into an existing list. This is the syntax by which you can append the elements of a new list into an old or existing one. To see the syntax in action, here we have a variable x with a list of integer values of 1, 2, and 3. We would like to append a new list to variable x with values 4, 5, and 6. Using the syntax presented, you can see that old list of x is updated with the new values. Now, let's look at the third important list operation. This is kind of different from what we have seen so far in syntax-wise. We learned how to add new elements to a list using the plus operator, or using the multiplier operator to repeat the elements of a list. Now, there is another technique, which is by using an append method in Python. In Python, a method is slightly different from a normal function, but do not worry about it now, as we will see the difference between a function and a method in depth later in this course. For now, an append method will be called a function. To append a new element to an existing list, you can follow this syntax. First, you will have list variable to which you want to append a new value followed by a dot. Then the append function, whose argument is the new value to be appended to list. This syntax means that we are applying the functionality of the append function into the list name, specified with a specific argument new value. So let's take an example. Here we have a variable x with a list of integer values of 1, 2, and 3. We would like to append a new value to variable x with a value 4. Using the append function syntax presented, you can see that old list of x is updated with the new value. Now, let's look at the fourth important list operation. We previously learned how to access the elements of a list using an index, which corresponds to value in the list. In this case, we are providing the index and the output will be the value located at that index. However, what if we want to do the opposite? Meaning that we have a value that we need to locate it in a list. For example, we know that the value 3 exists in the list variable x, so we need to know where is it located. To do this, we can use the index method. This is the syntax of the index function. You can see that it is similar to that of the append method. The input to this function is the value to be located, and the output will be an index where this value is located in the list. Let's take an example. Here we also have a variable x with a list of integer values of 1, 2, and 3. We would like to the location of the value 3 in the list. With the index method, you can see that indeed the index value of the integer 3 is 2. However, trying to locate a value that does not exist in a list will present an error message.